Okay, now we're going to talk about multiplying decimals using rational numbers, which also includes integers. We still have to use those same integer rules that we've been talking about for about 3 weeks. Okay? First thing with any multiplication problem is we have to remember multiplication is commutative. That means you can move them back and forth. If the book or the problem listed to you on a test says 6 times 3.7 and you want to put the 3.7 on top of the multiplication, you remember you can always reorder those. Reordering is fine with multiplication because 5 times 3 is the same as 3 times 5. Okay? So these are really easy. Nothing we haven't done. We know our times table, so this is all good. So our first example is on page 106. It says negative 9 times 0.4. And remember, I do not require that you write this 0. Okay? I would write this problem as negative 9 times 0.4. When it does not hold value, you do not have to write it. Just a little reminder. So our first step is to write the problem. Step 2. Step 2 is a big one, and we're going to do it mentally. Ignore the decimal. Okay, and a lot of you say, well, that's what makes the problem. But we don't need that decimal until the very end. We'll come back to it later. Okay, we're going to ignore it for now. And we're just going to look at the whole numbers. We have a 9 and we have a 4. 9 times 4 is 36. So we're going to do the math next. Step 3 is do the math, or do the multiplication. That's not going to fit. Okay, so I got 36. Step 4, check the sign. Okay, you know what I mean by that. Check the sign, put the sign in your answer. We have a negative 9 times a positive 4. A negative times a positive is a negative. So we put that sign out there. Now we're going to go back to that decimal I told you to ignore. So step number 5 is count the digits that exist behind a decimal point in the original problem. Step 5 is count the digits. That exist behind a decimal point. In the original problem. When I count those up, there's only one digit right there. Can't really see that. One digit exists behind a decimal point. So that means I have to have one digit existing behind a decimal point in my answer. So that's where I place it in your answer. Place in answer. Okay, so because I have one digit behind the decimal point, I have to have one digit, there it is, behind the decimal point in my answer. So my answer is negative 3.6. Okay? We're going to do a little bit harder problem with some longer decimals, and we're going to use example number 24 for that. Problem number 24. It says 4.31, and that's a times dot, but you can still do this just like you have done for years. Negative 9.5. And we don't have to line up these decimals. That's only with adding and subtracting. With multiplying, we're just going to put them out there because we're going to ignore them. Step number 2 says to ignore them. Now I'm going to do the math. 5 times 1 is 5. 5 times 3 is 15. 5 times 4 is 20 plus 1. Placeholder 0, just like normal. 9 times 1 is 9. 9 times 3 is 27. 9 times 4 is 36 plus 2 is 38. We add those up.
Yeah.
And we get this. Then we have 1, 2, 3 digits behind a decimal point. There are 2 decimal points, but they both exist. So we count all the digits behind. So then we put 1, 2, 3 digits behind our decimal point. Okay? I don't know if everybody in the back could see that. 1, 2, 3 digits exist behind a decimal point. 1, 2, 3 digits exist behind a decimal point. A positive times a negative is a negative. So now we have completed all 5 steps.